Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Rogue Planet with a Magnetic Field 200 times Stronger than Jupiter's. Now in 2006, an object with designation SIMPJ 013656.5 plus the rest of those numbers was detected through a near-infrared slash optical, and optical means visible light, survey. The object is 20 light years from Earth. From its spectrum, it was determined that the object was a T2 to T2.5 brown dwarf and the brightest T-class brown dwarf in the northern hemisphere, and therefore a good candidate for further study. Now, brown dwarfs are believed to be substellar objects or objects between a star and a gas giant planet. There are several different types of brown dwarfs, M, L, T, and Y. Brown dwarfs emit mainly infrared light and are thus not very bright in visible light. The brightest and youngest brown dwarfs are the M-type brown dwarfs, and the faintest and oldest are the Y-type. Brown dwarfs are thought to range in mass from 13 times the mass of Jupiter to about 80 times the mass of Jupiter, but to have a radius which is very close to Jupiter's radius, which would make them much denser than Jupiter. And here's an artist's impression of a brown dwarf. The objects are expected to look magenta or orange in visible light, and although there are also reports that some may look blue. Now, in 2009, this object, SIMPJ013, was discovered to have a variability in the amount of light it emitted with a modulation period of about 2.4 hours, which was attributed either to changes in surface features, which may have been due to weather evolution in its atmosphere, or differential rotation, which means different bands of atmosphere rotating at different speeds. In 2017, it was discovered that the object was part of a group of about 20 co-moving stars called Carina-Near stellar co-moving group. But since the stars in this group are thought to be very young stars, i.e. no older than 200 million years old, the brown dwarf would not have had time to burn through all its initial deuterium to now be a T-class brown dwarf. In other words, the brown dwarf, since it's part of this star group, could not be more than 200 million years either. And it's supposed to take longer than that for a brown dwarf to burn through its initial deuterium in order to become faint enough to then be a T-class brown dwarf. Now, this meant that it had to have a much lower mass to start with. It was therefore determined that the object had a mass of only 12.7 times the mass of Jupiter, and was therefore right at the threshold of the mass at which an object is supposed to be able to burn deuterium, actually a little lower. That meant that the object may be a planet and not a brown dwarf. But if it was a planet, it was a planet that is not orbiting any star and was therefore a rogue planet. Now, in 2018, the object was studied by the VLA, which stands for Very Large Array Radio Telescope. It's in Socorro, New Mexico, and it was discovered that it had significant radio flaring, which indicates the object's ability to produce aurora. Its magnetic field was also measured to be 200 times stronger than Jupiter's. A planet that is able to produce such a strong field was not likely, as only a star is supposed to be able to have such a strong magnetic field, especially if the planet does not orbit a star, since a star solar wind is supposed to make a huge contribution to a planet's magnetic field. Now, there are several problems with all of this. First of all, the mass of an object can only be measured if there is another object rotating around it. Then from the period of rotation, Kepler's third law can be used to determine its mass. But the mass attributed to this particular object does not come from any such process. It comes from the accepted theory of stellar evolution, which is based on stars and brown dwarfs being made out of gas and gravitational collapse being stopped only because of thermonuclear reactions pushing the gas outwards. This theory has been completely falsified by the presence of the Planet X system stellar cores in the solar system, some of which are much larger than the Sun, and the fact that they have solid surfaces which, even after having undergone expansion, still appear to be very dense. And the fact that these objects shed any material clinging to this hard surface indicates that what is left of the original object is the densest and deepest part of the object, and therefore the core. This means that stars have solid, dense cores inside them, just like planets. And here we see one of these objects, these stellar cores. As you can see, it seems to be striped. So, and the object is shedding this material that is making up its stripes. The stripes are, of course, associated with the magnetic field that the object must generate. And as you can see, the surface here, it's solid and dense. There are what looks at first seems to be grooves. These are actually fissures because this is a large object. And this means, indicates that the object has undergone expansion. The core has expanded. And if the core has expanded, even though it's so dense, you can imagine that the layers above the core expanded much more, which led them to break up and eventually being shed, also because these objects have very low gravitational fields. And I'll explain why further down. Now, in addition, the so-called SDO eclipse season, which is not at all an eclipse, but rather the sun going dark, shows that there are no thermonuclear reactions occurring inside the sun. As if there were, there would be light continuously coming from inside the sun, and it would be impossible for its surface and atmosphere to stop emitting light. And you can see what occurs here during the so-called SDO eclipse season, where it's attributed to the Earth covering the sun as far as the SDO satellite is concerned. And so that would cause the sun to become progressive, or the surface of the sun not to be observable by the satellite, because the Earth would be in front here. And the Earth, according to the SDO satellite, would look much larger than the sun, because the satellite would be much closer to the Earth and behind the Earth. And so the Earth would then, by the time this amount of the sun would be covered by the Earth, then the Earth would be here, about where the blue line is. So this part of the sun would be covered if this was an eclipse, and the part above would not be covered. However, this would mean that the sun's corona, or this part of the sun that's below it, including the corona, would still be there. It would not be covered. Anything above this line would not be covered. So that means that there should be, that piece of the corona is actually missing. If we actually place the line further up there, then we'd have to ask, how come this part of the corona is not covered? It's still there, but it's not covered. So what this actually shows is that as the darkness progresses along the face of the sun, that the corona shrinks back. And this part of the corona shrinks back because there's less light being emitted from this section of the sun. It's not that it's being covered. If it was covered, if part of the sun was being covered by the Earth, we would still see the corona that's not being covered, and all of it. So this part here would still be visible there, but it's not there. It's missing because this is not the Earth covering the sun. This is actually the corona shrinking back as darkness progresses across the face of the sun. And we can also see that at the edge of the darkness, there's never any of these cellular-like structures that we see on the sun that are partially covered. We would expect some partial covering. As you can see, this blue line here, it just cuts across. Wherever it cuts across, if it cuts across some whole structure on the sun, perhaps this one, then the top part of it is visible and the lower part would not be visible. We never see structures that are half there that seem to have been cut off by the Earth's presence in front of the sun. It's as if these structures are complete, perfectly edged, as if they are either on or off. Because this is what we are seeing. We are seeing the sun turn off sequentially from the bottom upwards. Obviously, as some object interacts with it and decreases the electric potential on the sun goes progressively dark, band by band, upwards in this case. So that means that in the section that's about to go dark next, there's a decrease in light emission in that section, and the corona actually shrinks back there. And this is what we observe. So what we are seeing here is not, there's no way this is an eclipse. This is the sun going dark. And it's irrefutable when we look at what happens with the corona. And in other articles, I show more of these images, and it shows that when the darkness is here, the corona is shrunk back here, and further up, it shrinks back, say, to there. It's never covered. It's always shrinking back, showing it's not an eclipse. And for more details, you may look at article 291 entitled "The Sun Disappears, Day Turns into Light." So furthermore, interactions with stellar cores have periodically left gashes in the sun's atmosphere or corona, which reveal a semi-solid or semi-molten type material beneath the corona, which does not appear to emit the same amount of light as the corona. This means that the sun has a gaseous atmosphere, a semi-solid layer below that, and logically solid layers below that. The core would then be several layers below the visible layers, as it is in the case of planet Earth. Most importantly, it means that the sun is not a gaseous object. The sun is more like a planet, mostly solid, with a gaseous atmosphere, which is emitting light due to a very large electric potential difference across it, which places it in plasma arc mode until something happens to drop the potential and the sun then stops emitting light. And here we see the close-up from an SDO image in 171 angstroms from August 25, 2017. On the sunspot group AR2670, which previously was known as AR2665, so it had already made a full turn around the sun, and it was being viewed again, the same sunspot group. And this dark region was there before, and it's still there again. And so what we see is this this dark crater-like blemish on the sun. And this blemish appeared after a CME on July 23rd, 2017, so more than a month before. And so we see this dark blemish close to the sunspot group. And the circular shape of the blemish suggests that it may be a crater-like structure made of semi-solid type of material. The fact that it stayed so long suggests that it must be semi-solid. It's not gaseous. and it must be made of material from a deeper layer of the sun that is not often seen. The blemish persisted for months, indicating that it could not have been a discoloration of a gaseous substance. It shows that the sun has a substructure which is not gaseous, it's semi-solid. Now, all this shows that planets and stars are not that different. They all have solid, dense cores, and any light emission comes from the atmosphere. Even the Earth emits light because there is lightning in its atmosphere. Stars and planets also generate energy in their cores through the same process of radioactive decay or fission of heavy nuclei. The larger the object, the larger will be its core, and therefore the more energy it will be able to generate, which will give rise to a larger electric field in its outer layers, and therefore a larger electric potential, leading to increased light emission. However, even the use of Kepler's law for determining the mass of an object will not give the correct result, because observing stellar cores in the inner solar system has shown that these objects do not interact gravitationally like normal objects. These objects are also very low in energy, which is why they drain the sun of energy. When a low energy object makes contact with a high mass object, energy flows from the high energy to the low energy object, just like heat flows from hot to cold objects. And this is illustrated by this diagram here, where we see a hot and a cold object. They make contact, just like stellar cores make contact with the sun. They actually draw material from the sun and make a connection with the sun. Then they draw energy from the sun through the matter that they are drawing, and through the fact that energy flows across from the center of the sun to the object. This also heats up this region close to where the contact is being made. So this becomes high energy, high electric field region, which is then subject to more CMEs and possibly solar flares occurring in this region. So this means that an object close to a region on the sun is more likely to increase the activity and then cause a CME and a solar flare to occur, as occurred on July 23, 2017. And obviously the object made a huge impression on the sun. It left this huge blemish. And this is also because these objects draw a lot of material from the sun. So this section obviously where material was being drawn and led to the creation of that blemish. Now, so stellar cores absorb energy in the form of photons from the sun, indicating that they are low in energy. They furthermore do not respond to gravity as normal solar system objects do, which shows that the gravitational constant in Newton's law of universal gravitation is not constant, but is dependent on the energy in the form of photons inside the particles making up an object. The photons or energy initially come from the core and are released whenever a heavy nucleus splits into two lighter nuclei. This photon energy is absorbed by particles near to where the reaction took place and flows from particle to particle until it is distributed throughout all the matter. This sharing of energy from particle to particle, however, takes time, so that the material closer to the core maintains a higher energy and temperature than the surface in the case of planets like Earth. This therefore shows that heat transfer is actually photon energy transfer, and since photon energy is connected to gravity, it is also gravitational energy. Now here we see the 2007 stellar core, which traversed the sun inside the sun's corona, and we see it here entering the corona. We can see the part that's still outside the corona, that's dark along against the background of the corona along the edge of the sun, and the part that is inside the corona is now red. Here the whole of the object is inside the corona, so it all looks red, and it traversed the sun. It took 10 hours to do so, and here it's starting to exit the corona. So this object was in the sun's corona. Its size could then be determined through a size comparison with the Sun. It was about 2.2 times the size of Jupiter. It took the object 10 hours to traverse the Sun, so its speed could be calculated. It was 39 kilometers per second, or 24 miles per second, which is a much lower speed than the Sun's escape velocity of 616 kilometers per second. And this means that this object should never have left the Sun if it was a normal object, if it had enough energy. And this means that this object was not interacting gravitationally with the Sun as a normal solar system object. And it had a very weakened capacity to gravitationally interact. And for more details, you may look at Article 153 entitled Planet X, Escape Velocity and Gravity, and Article 210, Stellar Core Gravity, Tidal, and G is not constant. Now, in the case of stars, the electric field generated in the outer layers is so high that the temperature becomes, that the atmosphere becomes plasma in arc mode, which in turn generates extremely high temperatures in the atmosphere. The stellar cores in the solar system have shown that the accepted theories on how stars work and evolve are wrong, and therefore the mass, radius, and age of stars, when determined through models based on this wrong theoretical understanding, are wrong. This means that what we really know about this object, the SIMP J013, etc., with any confidence, since it was gained through observing the object rather than through the application of theory, is that it mainly emits infrared light and that it has a huge magnetic field. Since the energy in a young star must be higher than in an old star, and that energy will be associated with the light the star will be able to emit from its atmosphere, a young star is likely to be bright and emit higher energy radiation, i.e. more gamma rays and X-rays, whilst an older star is likely to emit lower energy light such as infrared light. This means that this object is most likely an old star. The strong magnetic field also indicates that the object is most likely a star, as planets are not likely to have a core large enough to generate such a strong magnetic field. What this then indicates is that an aging star's magnetic field is maintained for much longer than its electric and gravitational fields. In conclusion, observation of the brightest T-type brown dwarf in the northern hemisphere, when viewed through the understanding of what stellar core observations within the inner solar system have provided, suggests that the object in an old or energy-depleted star or a stellar core, and that stars or energy-depleted or star, and also in stars, maintain a strong magnetic field for much longer than they are able to maintain electric and gravitational fields. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.